Okay, we're going to start off with our first lesson in trig, and it is a radical review. So, to start off with, we're going to do a practice. Let's simplify. We'll take the square root of 54 Remember, when we go through these, to do this, we need to break them down into their component parts. So 54, factors of 54 are 9 times 6. And we can break each of those factors down further. 9 is factored down into 3 times 3. 6 is into 2 times 3. Now remember, to pull something out from under the radical, we need to have a pair of them. So in this case, we have the pair of 3's come out because that's 9, and the square root of 9 is 3. So the 3 will come out to the outside of the radical. And what's remaining, the 2 and the 3, have to stay inside. So 2 times 3, what remains inside is the 6. So 3 root 6 is our solution. Okay. If we look at another one, square root of 120. And as we're going through these videos, hit pause. Take a moment to try it, and then come back on, hit play, and go through and see how the solution comes out. Looking at this 120, we've got factors of 12 times 10, we can very easily see, and then we can go from there. 12 breaks down into 4 times 3, 10 breaks down into 5 times 2, and the 4 breaks down into 2 times 2. Okay, that 4 was a perfect square, so that 4, those set of 2, can be pulled out and go in front. The other 3 factors, the 3, the 5, and the 2, they're all going to have to stay inside. So when we pull this back together, the pair of 2 comes out because it's square root of 4, means it's a 2 on the outside. And on the inside, 3 times 5 is 15, times 2 is 30. That's going to stay on the inside because there wasn't a second factor that we could pull out as a perfect square. Okay? Next one. Sometimes we had a negative on the outside. Negative on the outside didn't affect anything. And the number on the outside doesn't affect anything. It's just got to be part of the factor that's put out front after we simplify the radical. So we got the 45. That's going to break into 9 and 5. And the 9 is a perfect square, 3 times 3. So we've got the 3's. One of them comes to the outside along with this negative 2. So we're going to have a negative 2 and a 3 being multiplied for the outside. The 5 is the only thing left for the inside. So the negative 2 times 3, negative 6 on the outside, and under the radical, the 5. We had some problems that had multiple pieces. (24) x squared, y cubed, z to the 6th. Okay? We do the same thing we did before, we just take it in parts. So the 24, we can break down into 4 times 6, which those break down into 2 times 2 and 2 times 3. That 4 being a perfect square means one of those 2's come out to the front. The 2 times 3 will stay inside. Okay? With the x squared, remember that is when we have a variable to deal with the same base. X squared is simply x times x. Well, that's a pair of x's, which means one of them will come to the front and there's nothing left underneath. So if we draw in our radical down here and start putting pieces under it and pieces out front, we had the 2 times 2, so a 2 came out. X times x means 1x comes out. Underneath, the 2 times 3, 6 stayed underneath. There were no x parts to go underneath. For the y's, y cubed is 3 y's. Y times y times y. So 2 of them means a y can come out and 1 y remains underneath. For the z's, we have 6 of them. Z times z times z times z times z times z. Well, for every pair of them, 1 can come out. There's 3 pairs of them. So it's basically dividing the exponent in half. If z to the 6th power means we're going to have z cubed outside, there's none left over. When we had y cubed, we can take the 1 less, y squared, cut it in half, and 1y remaining. Okay, I'm going to hit stop here and see how this turns out, and then I will finish off the other examples in a second video.